here is integrated 3. It's problem 9-79, and it says you've seen that you can calculate the values of the sine function using right triangles formed by a radius of the unit circle. Values of theta that result in 30, 60, 90 or 45, 45, 90 triangles are frequently used because their sine and cosine values can be expressed exactly without using a calculator. You should learn to recognize these values when you see them. The same is true for values of cosine and sine that correspond to the x and y intercepts of the unit circle. The central angles that correspond to these special values of theta are, oh good, it gave you all of them, 0, 30, 45, 60, 90, and then so on and so forth into all of the 4 quadrants of the unit circle. What these angles have in common is that they are multiples of 30 or 45. Copy and complete a table like the one below for all special angles between 0 and 360. So they listed all the angles. They just listed them for you so that you would know. We're going to go from 0 to 360. We're going to make a table. And so I kind of want to remind you how we can write these. Like, I don't know if you remember the video of the angry math guy, but we're going to start right here. And then we're opening up angle. Here, let's use this little short thing. We're opening up angles like this. Like that's a quarter, that's a, well actually, remember that the half of the unit circle is pi, and that all the way around is 2 pi, and we found that out when we we did some folding and cutting, and we found out there were 6.28 radians in a circle, which was 2 pi. So if you're just looking at this part, from here to here, that's half pi, right? And that's a full pi. And then that would be pi and a half, or I guess you'd say 3 pi over 2, and all the way around is 2 pi. Okay, so so we have some measurements for those. This one would be 0 degrees. This one is 90 degrees. This is 180. 270, 360. Okay, so all of these, all of those angles, they have radians that are associated with them. Like this one here, since half a circle is pi, this is pi over 2, isn't it? And this one's pi, and this one's 3 pi over 2, because that's 1.5 pi's, and this is 2 pi. And then this one right here, if halfway around the circle is pi, this is a fourth, this is pi over 4, isn't it? So now I can count by fourths of pi's. I can go 1 pi over 4. That's 2 pi over 4, which is half a pi. This from here to here, that's 3 pi over 4. And that would be 4 pi over 4. And then if I keep going, this right here, wait, where is it? This middle one right here, if I'm counting by pi over 4, I got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. This is 5 pi over 4. This would be 6 pi over 4, but really we reduced it to 3 pi over 2. This right here, that could be 7 pi over 4. And that's 8 pi over 4. So all these ones that are kind of like, they have 4s in the denominator of the fraction, These all came from the 45-45, the 45-45-90 triangles. Okay. We're not asked right now to get the sine and cosine of them, so I'm not going to bother too much with that. But we know that these little ones right here, this one's actually 30 degrees, and this one's 60 degrees. So let's go ahead and, we're going to run out of time if we don't. Let's go ahead and try to, let me get closer. Try to get some of these written down. So 0 degrees, how many radians is that? That would be 0 radians. 30 degrees, I don't know if you can tell. I'm cutting my pi. I'm covering up the bottom because just the top part is pi. I'm cutting it into 1, 2, 3, 4, 5, 6 pieces. See, this is like remember we were eating pie on Pi Day? I'm evenly cutting my pie into 6 pieces. Right, because half a circle equals pi radians. So I've got 1, 2, 3, 4, 5, 6. These are sixths with a TH on it. So this is going to be 1 pi over 6. This would be 2 pi over 6. But I'm going to reduce it to pi over 3 if you don't mind. This would be 3 pi over 6. 3 pi over 6, that's just a pi over 2, okay? That's 4 pi over 6. So 4 pi over 6. Well, 4 pi over 6 is equal to 2 pi over 3. This is 5 pi over 6. And this is 6 pi over 6. So we're going to put all these in, let me use a better color, more darker color. So we said 30 degrees, that was pi over 6. 45 degrees, we already got pi over 4. 60 degrees, that's pi over 3. 90 degrees, that's pi over 2. It's autofocus. 120 degrees, that was 2 pi over 3. 135 degrees, that's 3 pi over 4. 150 degrees, that was 5 pi over 6. And 180 degrees, guess what? That's pi. And 210 degrees, well, I didn't keep going here. So if that's 5 pi over 6, let's keep going. 5 pi over 6, 6 pi over 6. This must be 7 pi over 6. That's 8 pi over 6 right here. What's 8 pi over 6 though? Isn't that 4 pi over 3? So I got 7 pi over 6. 8 pi over 6. That's 9 pi over 6, which is, it reduces down to 3 pi over 2. There's 10 pi over 6. Well, that's 5 pi over 3. 11 pi over 6. And that's 12 pi over 6, which is 2 pi. So let's get these all written in here. So we've got 210, that's 7 pi over 6. 225 is 5 pi over 4. And I'm just going to have to write these down really fast because my video is too long and they're going to cut me off. 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and 2 pi. So I feel like the Angry Math Guy actually explains this way better than I did in this video, so I would suggest watching his video as well. But this is the answer to your homework problem.